Hi everyone, seeing you all after a long time, and today we are going to discuss today's contest. So first question was calculate digit sum of the string. So I will directly discuss the example. So in first example we have some s means some string is there, right? And we have the k. And what we are planning to do is we have to create the group of k's, means in this case it is three, right? So we have one 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 and a one one two two two, and I guess one more two two three. Correct? Am I going right? Yes. uh so what you have to do, you have to create the group of threes. So pick first three, then second three, third three, and whatever is remaining, right? So this is your first task. Then what you have to do, add all these characters, right? So if you will all these add all these character, it will become 3, it will become 4, it will become 6, it will become 5. So now this is your new string, right? 3 4 6 5. Do the same again, create the group of threes, one group, another group, right? Now add these all, so it will become 13, it's 5. This is again a new string, right? 135. But now you have to stop. Why? Because it is saying that continuous this task until the size of this string is greater than k, but now its size is equal to k, right? So you have to stop and return this string. That's why we are returning 135 in this. Same thing you have to do in this case, right? So this is the problem. And the code for this particular question is same only, means whatever I'm just explaining here, I will do the same. Wait a second. So what I'm doing, I'm checking if a string size is greater than k. Go inside, I created a string builder in Java. That's fine. Now starting from the first index, means I is equal to 0 and maintaining the total. And if I is less than s dot length, whatever the string length, so this string length, go inside, add in the total, do the I plus plus. If I is divisible by k, means if the group is of size k, means when, so okay, got it. So here its index is 0, its index is 1, its index is 2, it's 3, right? So now you can see 3 is divisible by k, which is k is also 3. So here you know that you already created a group, right? So you have to add that group in our string builder. Means I am on the go, I'm going to create the string, new string, this one 3 4 6 5. So that's what I'm doing. And now I'm replacing our s with the new string and doing the same task again and again. So this is a solution. This is a very basic solution which I did here. Now we can jump into the second problem. So which is minimum rounds to complete all the tasks. So I will directly discuss the example. So this is the array which is given, right? Some numbers are given in this array. And one thing you have to do here, that you can complete two tasks of same thing. For example, if this is this is the array, only this is the array. So either at the same level, means in one go you can complete either three tasks or two tasks only. You cannot complete one task, you cannot complete four tasks. Only possible thing is two or three, right? So if I will just say like you have this array, so how many attempts you will take to complete all the tasks, right? So what I will do, I will pick two first and then the remaining two. Now you must have the question why I didn't pick the three first, right? Because if I will pick three, then one is remaining. Got it? And this one you cannot complete, because either you can complete two or three. That's why I picked two, then two. Now, the only thing you have to remember here, that you have to return the number of tasks. So I will explain one thing here. If you have a number, for example, 2, which is coming one time only, that is the only possible case where you cannot complete the task. In other cases, you can do. For example, 2 is coming two times, you just complete two tasks in one go, right? You have 3, complete 3 tasks in one go. You have 4, complete 2 and 2, means in two attempts you can complete it. If it is 5, you can pick 3 then 2, right? This is the, so only possible case is 1, when there is only one count of that, one frequency of that number, you cannot complete it. So now next thing what you have to do, you have to find um, how many attempts it will take to complete twos, right? Means now you have calculated the frequency of each number. So for in this, if I will take the first example, the frequency of 2 is 3, like this, there is 1 2 2 and this is 3, right? A frequency of 3 is 2 and frequency of 4 is 5, right? So now you have to find out how many attempts it will take to complete 2, 3 and 4. So first take 2, how many attempts it will take? One attempt only. How you are calculating? What is whatever is the frequency, just take the divided by 3, and then take, actually after dividing it by 3 you will get 1, right? But you have to take math dot seal, means calculate the seal value. Why? Because if it is, the frequency is 4, then then also you will divide it by 3, you will get some value, right? 1 point something, and take the seal of it, right? Because if you have 4, then you have to divide it like this, and you will take 2 tasks, right? So this is little maths here, just you can understand it. If you don't, please ask me in the comment. So in this way you can find like how many attempts you will take to complete every value, right? And in the last you have to just add it. So that's the solution for this. Now I will just explain my code. So I sorted the task, right? And then this is like value is equal to task 0, I just initialized it, and count is 1, and iterated through the complete array. So if value is equal to task I increase the count. Otherwise, what I have to do, if count is equal to 1, then return -1, because you cannot complete the task. I explained, right? And else, what you have to do, you have to calculate the seal, means how many attempts it will take, and add it to the total, whatever you will return in the last, right? And then means just this is a new thing, like value should be task I and count is 1, because what condition I am taking here. If value is equal to task I, means it's equal to previous value, then increase the count. Otherwise, so means new value is not equal. New value is not similar to previous value. So that's why I changed the value here. And then in the last, you have to just return the total. So this is the solution for this problem. Now I'm going to jump into the third problem, which was like, you can say, implementation heavy. So what you have to do here, I will explain. Okay. So this is a complete, you can say 2D array we have, right? All the numbers are positive in this array. So the task you have to find is, if this is an array, right? This is an array. Okay. Got it. Now your task is to find the number of trailing zeros in one of the cornered path. What this cornered path means, I will explain. So if you are starting from some point here, you can move in any of the direction, right and bottom. So like in left also and top also, anything is possible. So from here you cannot move to top. So I'm moving, for example, I'm moving to bottom like this. Now I choose to move left or right. Okay. So I choose to move in the right. So I just got here, I cannot move more. So in this particular case, I just have one corner, right? I just have one corner. You cannot move like this. This is not valid. This is not valid. This is not valid. And also, this is not valid because you are returning, right? This is also not valid. Either this or just simple vertical traversal, or means from top to bottom or left to right. So at most you can have one corner. So this is the problem, right? Now you have to multiply all these numbers and find out the maximum trailing zeros you can have. So what is the quality of trailing zero when it comes? For example, I'm multiplying 5 by 2. It has trailing zero, right? 10. So how you're getting it? So there is one, again, simple math trick, that count the number of fives. So count the number of fives. For example, you have 6 5 in some number, and count the number of twos. For example, you have 7 twos in that number. You can, after multiplying, you can say that you will have 6 trailing zeros. Why? Because every one and every 5 and every 2 will create 1 0, right? You can see here every 5 and every 2 is creating 1 0. So you have to just count the 5 and 2s. That's the new question for you. So what you will do to solve it? Okay, now I'll explain a little more here how to solve it. So what you will just do first, store for all values number of fives and number of twos. For example, 23. How many fives and twos are there? No five, no twos. For 17, no five, no twos. Here, one five, but no twos. Here, two twos and one five, right? So in this way, you will store. So you will, what you can do, you can create one array to store fives, right? And another array to store twos, right? So this is the first task you have to do. You have to calculate the number of twos and number of fives. Now, what is the next task? You have to do the cumulative sum. Why? I will explain. So I should actually remove all this and then do from starting. Okay. So I have calculated number of fives for every value and number of twos for every value, right? Now what I'm going to do, you know, you can have maximum one corner, right? So for example, if you are assuming corner is at some index I comma j, right? This is I comma j. So how you will get the maximum twos and fives using this corner? So if cumulatively you are doing from here and calculating number of fives and zeros, so you will store number of fives and zeros from the top, means cumulative sum you can say. From this direction also you will calculating the cumulative and storing number of fives and twos maximum here. From this direction also doing the same, storing number of cumulative fives and twos here, and this direction also, right? Now you have to choose two directions only, means you can have, you can come from here, move to this direction, come from here, move to this direction, right? Come from here, move to this direction. So you can choose two directions, which like after the summing all the twos and fives of them gives you maximum number of zeros, right? So you have to pick two directions. So what I did, I just like picked two direction and checked if it is creating, means I have one max variable, and I will just add these twos and I will check like if this is giving me maximum number of zeros or not. Then check these two, how many combinations will be there? 4c2. Okay, so this I did, and I got the number of maximum zeros for this, right? For this, if this is the corner. So I did the same procedure for every INJ, right? But to do this procedure, you should have the cumulative sum from the top, from the left, from the right, from the bottom, right? You should have that. That's why I calculated the cumulatives. That means I created four arrays, four different arrays, one for left cumulative sum, one for right cumulative sum, one for top cumulative sum, one for bottom cumulative sum. And I did that. And after this is simple, just pick any of the IJ and check which two direction will help you, right? So code is very big, I will say. I'm just trying to explain what I did. This is very big, sorry for this. But you can like, you can solve it in your way and try to minimize the length of this code. That's fine. Okay. So I did the same thing. I created so very well, I think just ignore it and try to code yourself. If you will have any doubt, you can definitely ask me in the comment section, right? Now we can jump into the last problem. So which is the longest path with different adjacent character, right? So this is the problem. So we have a tree. We have a tree in this particular problem, and we have a given array which is telling us that every node, like which is the parent of that particular node. For example, this is 0 index 1 2 3 4 5. So -1 is means that's a root. 1 has the parent 0, 2 has the parent 0, 3 has parent 1, 4 has the parent 1, 5 has the parent 2. And you can see in this particular picture that this is true. And now you have string a b a c a b a c b e e e e. Okay, and then you have to tell, what you have to tell, you have to tell the longest path in which two adjacent nodes do not have the same character. For example, I cannot consider this path, means 5 2 0 1 4. Why? Because this particular node and this particular node both have a, and this both have b, right? And what this character means, I will explain. This is a given string, right? So 0th node will have a character, first node will have b, then second node will have a again, then so on, right? So that's what we assigned here. Now you cannot have this path, right? But you can have maybe this path. Why? Because 0 1 3 A, B, C, all are different. No two adjacents are same. So you have to return the maximum length, not the path, right? The length of the longest path. So you don't have to remember the exact path which is giving us the longest path, right? But you have to return the length. That's important. So what you can do, actually, this I found somewhere in the LeetCode also earlier. I don't remember, but similar question was there. So if, for example, you are starting from root, okay, you are just doing DFS, okay, you are just doing DFS here. So this is a tree for you, right? 2 1 5 3 4. So if you are in root and you are doing DFS, you will go in left, you will go in right, and what you will return to this node from left. You will tell this node like what is the maximum length we can get from the left side. From the right, you will get like what is the maximum length you can get from the right side. If there is one more node, you will say like what's the maximum length I can get from this side, right? But in this only twos are there, so that's fine. But in this there are three, so you will return maximum from here, maximum from here, maximum from here. This is the DFS, right? And now what you will do, you will, if this is the root, this is the node which is in the longest part, just assume, right? So what you have to do, you have to find the two maximums out of these. You will get a lot of, like, for example, this is the current node. If you are doing DFS, you will go to all the children's, right? You will get some values from all the children, right? For example, you are getting v1 from here, v2 from here, v3 from here, v4 from here. And what these v's are, these are telling, if this is the node, then what is the maximum length we can get here, right? So in the DFS you are doing that. If v1 is the maximum, I'm returning to the node. And out of these four, you have to pick two, means two values which are maximum. And also those, if for example v3 is giving us 4 length, this is giving us 3 length, this is giving us 2, this is giving us 1. But if this has character A and v3 is also character A, you cannot consider it. Why? Because this cannot give you the longest path which do not have adjacent similar character, right? So in this A is there, you cannot consider this. So you have to ignore all the v's which have the same character as node. And in the rest of the v's, in the rest of the v's, means whatever we are returning to the node, in the rest of the v's, you have to find two maximums, right? Max 1 and max 2, means top 2. You have to find the top 2. For example, this is 1, this is 2, this is 3. So this you cannot include because this AA. For example, this is C, this is D, this is E. So all other you can include. And now the top 2 is this 3 and this 2, right? So if you have this 3 and 2 as a top and you are considering this node as a path, so what is the path you can get from this side to this side, right? So 2 plus 1 plus 3, right? So if this is greater than your current maximum path, you can return in the last, right? So you have to do this thing in every node. So I will start from root, right? I will call the DFS in this. So DFS is a solution and the time complexity will be order of n because you have to visit every node once. I think I will try to explain this with the help of the example, right? So let's go to the, not example, sorry, the code. And if you will not understand, please let me know. I will try to explain it in the comment also using my typing. Okay, so see this code, right? So in this code, you can see like I have created one DFS here, right? DFS function. Okay, wait a second. So I have created one DFS function here. So this is the longest part. This is the main function I have created a global max where I'm storing the maximum value, right? And then I have created a adjacency list or adjacency map, you can say, right? So this I have. So this I created with the help of this array, parent array. So this is simple, just to go visit through this and like keep on adding. If one has parent 0, right? So in the 0th key, you have to add this node because it will help you in the DFS, right? And at the same time you can find the root, because whatever node has the parent -1, that's the root for you. Then call the DFS in the root, and in that DFS what I'm doing, I'm maintaining these two, means these are the two top values. So I initialize with 0, and then this is the like, if the current node is something, I am just finding all the childs of it, right? I'm iterating through all the childs, calling the DFS for those childs. And if the our node's character is equal to the child character, then continue, because you you don't need whatever they are returning, right? Otherwise you have to check if that particular value which I'm getting from its child, it's greater than value 1. If it is, then means for example, what if it is, okay, these are value 1, value 2, if value is greater than this, right, then store this value in this and shift its value to this. Why? This is storing the maximum value, and this is second maximum, right? So you have to shift the max to this and value to this. Else if value is greater than value 2, means it's less than value 1, it's less than value 1 but greater than this, so store this to value 2 directly and just leave it. So that's what I'm doing here. And in the last I'm checking if value 1 means top two value, value 1, value 2 plus 1 is greater than max, then updating the max and returning the value 1 plus max. So whatever, so value 1 is storing the maximum value, right? Like I have solved. So this is the node. Okay, this is the node, right? I've solved it. I've found v1 and v2 are the two maximums. V1 is the maximum, and what I have to return to the parent of this current node, right? I will store the top plus 1. That is the path which we can return to the parent, right? So that's what I am doing here, and this will actually solve our problem. So time complexity I explained, right? It's order of n. And thank you so much. If you have any doubt, please let me know in the comment section. I will try to resolve there also. And thank you. Thank you.